So when we get to the two-dimensional array, now we have our rows going up and down. Oops, turn my pen back on. We have our rows going up and down. And then our columns. And then, so when we start talking about building our two-dimensional array, again, these are all ints. So we're just going to go int. But instead of just the single, we're going to build it with double. And again, we'll call it ARR. And then we can do it one of two ways. We can do, again, new, and then the ints. And then we can go, what's this, 5 or 6. So we always do rows comes first. So we have 6 and then 5. Or if we're going to build it, so again, this is the same. So we go int array equals, and then we're going to go curly bracket, and then we're going to do, and that curly bracket is going to open up for the rows. And then the rows are going to be broken up as to, we'll go 5, 7, 10, 12, 15. Then we're going to close. I'm going to put a comma, and then I'm going to erase. I'm going to erase that. Give me 1 second. How long are we doing for? All right, so then we go to the next row, and when we do the next row, we're going to open up again another parentheses, 6, 9, 13, 17, 20, and we'll close off another comma, and then we'll go through and do that all the way until we get to the last row. So I'm just going to put some dots in here. So our last row will be 22, 28, 33, 35, 42, 42. I'm not going to have a comma here because I've ended, and then I'll have my closing bracket that corresponds with this one here. And that's how I will build a 2D array in code. Now, you're probably going to see these in graphic problems, and if you're not on the CS side, chances are you're probably not going to do any graphic problems, and if you are on the CS side, you're probably only going to do graphic problems in class. So unless you're getting deep into like touch pads and stuff like that, or touch screens, trying to figure out where the different the touches are on either the screen or on the pad. Maybe even you could probably even do this on like a phone pad or something like that as well. I will say there's a whole course, linear algebra, that covers this left, right, and backwards and everything else. And if you're CS, good luck, because you're going to have that. Ray, did you get an A on that? You probably got an A. All right. So Rows comes first, then columns. Oop. In linear algebra. Or is that a sore point? She got to be. That's crap. She know how to round up numbers. She's math, isn't she? All right. So I don't know why this is. Let's just fix this up a little bit here in this example. It should be read this way. The rows coming in the columns. So you would be at row 1, column 2. So I think the slide's somewhere in there where you got messed up. That is incorrect. All right. All right, so kind of a cousin to the arrays is the array list or the linked list. A lot of times, especially when you're dealing with a unknown quantity that you have to account for in an array, you're typically going to use an array list versus a regular array. Since in Java, you cannot just build an array with an unknown length, but you can create an unknown length of a list. So a linked list or an array list in this case, they kind of work the same when we start talking about our time and space complexities. So as you can see, we have a fixed size for the array. So when you say that your array is going to be 9 indices, it's always going to be 9 indices. On a list, you can say that your list is going to be 1 or it's going to be 100 the next iteration through. It's variable. It can always change. So you don't have to worry about having a fixed amount there. So when you're dealing with various pieces that you're inputting or something like that, a lot of times an array list is better than using just an array. It's a faster lookup. So for those of you who are aware of the big O notations for computations of time complexity and space complexity, the lookup for an array is constant. So if the array is of size 9, it's 09. So we're always going to consider that as an 01. And if the array list is linear, so it's going to be O of n, because we do not know how many items are in that array. We're going to assume that there's n amount of items. So then it's going to be n different times I have to look to find what I'm looking for. Inserting is O of n and deleting O of n for arrays. So my first insert into a list is going to be constant because I know it's going to be 1. But once I get and put in the second one, or I try to put it somewhere differently in the list, it's always going to be then O of n because I don't know where it's going to be. So it's going to take n times to find where I need to put it, or n times where I needed to delete it from. So, but if you're not, yes, you're probably not going to know anything about the ON, so don't stress over that. All right, real-life applications for arrays. Google's file system uses it. Image processing. A lot of AI and machine learnings use them. When we start talking about implementing a lot of the different data structures like stacks, queues, hash tables, heaps, use them then. Arrays, especially on NoSQL for databases. If you guys are familiar with the coding language JSON, type that into the chat. JSON is basically just arrays. They're just arrays of arrays. If you're thinking of, if you do any web stuff on the CSS side, basically the CS elements have an array of properties that are going to style them, and then those properties also have values. So basically, an HTML element in CSS has an array attached of styling. So scrollable views, playlists, news feeds. So arrays are kind of used in a lot of different programming applications. All right. So we're not talking about lists today. We were just comparing those in terms of the ease of use, and it's in terms of the time complexities, i.e., how much your CPU is going to have to spin its fan to cool down after all the operations have to occur between using the array and the linked list. Arrays aren't as complex as the list, so they're oftentimes utilized more often depending on the application in programming. All right, so strings. So strings are a Java type. They're not a primitive type. They're a special array because they are made up of different characters. So if you think of a string as an array of characters, then you pretty much know exactly what an array is, right? Because when we talk about like in programming 1, some of the exercises you're trying to grab a specific letter out or of a string. So you go char at, throw that method in here, char at. Not chat at. What did stupid autocorrect on Zoom? So char at, not chat at. The char at, so we're looking at character at, and usually you put in a number in there. So if I put in 7 into char at, I'm looking at that at index 7 of the string. So if we were, for example, to break this up right here, I'm just going to do that regular box that you see in arrays. So I have 0, 1, 2, 3, 4, 5, and 6. So strings has 7 letters, so I have 7 elements. So if, for example, I wanted to find the indexes of these basically characters, as if we will. So we would, let's just say we're going to use the small letter string and capitalize. So we're going to create a new, and it's just going to call it string. So here's our new string, right? And so essentially, we were looking at string dot char at, and we picked one of these 7 elements here. So for example, here, we know that this then would equal n. And it's a character, so it goes in single quotation marks, versus the string, if you remember, it goes in the double quotation marks. And then you can always use a lot of these different helper methods like compare, join, split. You can take the substrings out. So basically that's, okay. So you can do a lot of things with breaking apart a string, putting together a string with characters and stuff like that. So I guess I will be a little bit embarrassed when I say, if I looked at this last bullet first. So it's just instead of a array, it's a heap tree. So a heap where strings are. So, and we're probably not going to talk about heaps for a couple of weeks. So if you put that in the back of your head and remember to take that out when we get to heaps. If I remember, I'll mention it at that time. But suffice it to say, if you just think of it as an array, it just acts a little bit differently, and because it acts a little bit differently, that's why they call it a heap, and they have all these little different helper methods to pull it out, and that's why we have to have the .char at to find the index, versus if string was an array of numbers or something, then it would just be at index 4, for example. All right, so know how they're represented in memory. So basically, they're represented by their characters in memory. So a character, if you go back to your primitive data types, and if I am not mistaken, the character is at, what is that, 2 bytes for a character? I think that's correct. Maybe it's 2 bits. I don't know, whatever it is, but it's stored as characters. Hey, Selena, and not as a string itself. Because when we talk about the Java types and the primitive types specifically, that's where all of our storage is consumed by those primitive types. So you can't just quote unquote save a string to a certain amount of memory space. It actually has to be broken up into the characters. All right. So here are some of the basic operations for strings. So we can compare, we can join, we can split, we can search for substrings, we can replace, we can parse, we can find the characters in them, we can, and when we're talking about compare, so, all right, so the differences between the subsets, the substrings, and the subsequences. All right, I'm not going to get into the weeds on this because we're not really going to talk or do any real problem sets on any of these, but suffice it to say that the strings are broken down into the characters, and then you can also think of inside strings, you can have different subsets of the strings, and also strings can be within strings, and also there are also sequences within them as well. Some intermediate to advanced problems use hash tables. Yes. What do you call it? And then the other things that to remember about are that there's two libraries that are very effective when we're talking about strings in Java. And that's the string class. Oh man, just trying to draw. So the string class. So if you remember in like programming 1 and you had to build out your string objects basically. And what they wanted you to do is substitute your variable. So let's say we're dealing with money and they wanted you to have the two decimal places. If you remember those exercises, and you probably put in something like a percentage sign, and then which starts the coding process within the string, and then maybe a comma to delineate and put the commas in at the thousands place. So if it was $1,000, for example, it would be 1,000. And then there was probably a decimal place, and then 2 to don't say that we're going to go 2 decimal places in, and then probably the F, because that's the code for double. If you remember that. And then, you ended the string with the double quotes, and then there was a comma, and then you put in the, let's say, total variable. And that was all in this big thing. It wasn't printing, but we were string dot, what was that? Now I just use it too. It's not builder. Ray, can you help me out? You remember what that is? When you're building the string with the, doing like the decimal points. String format, that's it, thank you. I can't remember I even put that format. Yeah, string format, thank you. So that string here is part of the string class. And then you have the string builder. You might have done string builder at some point. I don't know if you do that in 1 or if you do that in 2. That's you just calling string builder and then maybe calling s equals new string builder. Then you're using the SB as and then you're concatenating your stuff together to build the string. Remember that? Maybe. Kind of like scanner. Or what else do we use that one? We use a ton of stuff that way. But being able to build strings and then manipulating those strings with these two classes are a key to being able to effectively work with them. Ooh. All right, so if you remember how to make strings into integers and integers into strings, remember how to do that? How do we build a string to an integer? Someone type it in chat for me. There we go. Integer, parse, and then you put it in there. In C++. Remember how to do it in C++, Jacob? So in Java, at least it's integer.parse. How do we then bring a, yeah, that's it, parse in. There you go. Thank you. All right, so how do we bring the string or an integer over to a string? All right, that'll work. Another way, the real way. Two-string, yes, that is it, two-string. All right. How about reversing a string? What's a helper method? Uh-oh. I lost all my chat and everything else. So if we take your last one, Ray, that's part of the string builder. I think you might have to use string builder in front of it too, but so if you were to go like, we put in like, probably just be doing this on the whiteboard, right? what that should come out as is, where's this yellow now? All right, how do we tell if a string has a unique character? By unique character, I don't mean like E being or O being unique, being the only one here, but being a special, like a special character. Oh no, all has all of the all unique characters. So yes. So if I was to type out like the alphabet, I have all unique characters. How do I tell? Unique characters. Is that one? I don't know. I'm gonna look that up. So basically, we're just going to create an array, or we're going to break out our string to different characters, and then we'll just search and compare the different characters to each other to determine if they're unique or not. No special flavor on that one. Sorry. How about if it's a palindrome? Ray, I want you to answer this one because we've done this already. How do you know if a string's a palindrome? How do you solve that? If I gave you a number 2, could you be able to answer it? Yeah, 2 pointers. So we use a 2-pointer technique. We look at the last character and the first character and compare, and then move in. Oh, what a palindrome was? No. We're just determining if it is a palindrome. How about anagrams? How do you think you do an anagram? Determine if they're anagrams. I'd probably go back and do the 2-pointer technique again, and because anagram is string length. Is anagram just the same word, but well, the same letters, but just a different word? Okay, Ray. Bye, Ray. So if you can kind of think about how to manipulate these types of um, um, examples, then a lot of problems that deal with strings and or characters become a little bit easier. All right, so our substring is a group of characters concatenated. Our sequence is a group of indices. In this case, the 0, the 2 going on, and the subset are just the group of the values. Okay. Whoa, whoa, whoa. So I already gave it away a little bit, the two-pointer technique. So basically, when we talk about two pointers, we're talking about arrays. Oops. We have an array. We have our indices. And then I have my values. All right. So what I'm going to look for is to go through with basically in programming, you're just probably going to call this like a write or fast or something like that. You're going to go through a for loop. And you're going to search through each indice to find the value that you're looking for. And that's going to be one pointer. Give me 1 second, guys. I had to pull my chicken out of the oven, sorry. All right, so we use a for loop to do one, but we can also, in that same for loop, we can also make one that goes faster or one that comes from the opposite side. So let's just say this one increments, this one decrements. Oh, decrements. So I could say I plus plus, and at the same time, we can use J minus minus. And as J minus minus comes through, and let me do the little dot that I had over there. So he's going to come from the last one down. He'll start at 4. This one will start at 0, and then at some point they'll either meet, and we'll stop when they meet, or we'll stop them when they cross over. It just depends what we want to do in our code. But so, for example, if we're looking at a palindrome, so I'm going to go and I'm going to erase this up here a little bit. So as we hit each one and we see 0, we hit 5, and then they may not, they don't necessarily have to go to 2, because if it's the middle one, they know it's going to be the same. So we don't necessarily have to do that in code. But as we go through, we would have in that for loop an if statement to compare, let's just say if left equals right, then we'll do something. And then else, if it doesn't, then we can say, well, it's not a palindrome. So that's just a quick example of how you would deal with a palindrome thing. So we can also go through, here are some examples, and go through with a pair or with 3 different pointers, and I can go through and I can find the sum or the greatest sum of certain numbers in the array. So let's say that if we go through, I could start at the first one and the second one, and then I could add it up, and I can get up with 3, and 3 will be now my greatest. Do that, and then we'll just slide these guys over. Oh, sorry. I'm going to slide him over to here. Let me erase this. So I totally messed that up. Change color too. So then we're going to change him to here. So he'll go here now. He'll go up to here. And then we have 5. So now 5 will be our greatest. Then we're going to move him over here and him over here. So now we have 12. So 12 is our greatest. And then we're going to move him up and him up. And then we have 9. So 9 is not greater than 12. So 12 is our highest sum. All right. What I have found, at least in my experience, is as I read through these problems, and if I can write them down on a piece of paper and get them to, like this, going through it, I find it's a lot easier for me to write the code to then deal with what I'm depicting on the paper. So remove duplicates in a sorted array. Again, we would just move 2 pairs going up the same way to each indice. So let's say we start with 0, 1, because we're sorted, and this is 1. So when we move to the next one up, so when these guys shift, and now they're here and here, they compare, and now they can then remove this guy from the array. So the Dutch national flag, if you don't know, I'm going to say it's orange, white, and blue. But basically, it's just partitions. You can use this Mexican flag or whatever. You want to use any of those tricolor Russia. I don't know if Mexico works too well because they get the crest in the middle of the flag. So, but in any case, you're just looking at groups of 3 and partitioning that way as another technique. They also call that the sliding window technique as well. All right, so different approaches. I think we've talked about this. One on either end, especially if we're doing palindromes, both starting at the beginning. So we can either start both at index 0 and move each one incrementally, or we can start one at 0 and 1 and then move them incrementally, and then same from the reverse side. So here's our little example we'll talk about. So we're given an array. We're going to find the length of the smallest subarray in it, which when sorted will sort the whole array. So as I look at this, I'm just going to draw an example of what I believe is what they're talking about. So I'm going to say 1, 3, 5, 2, 6. So this is what I've envisioned as an input for this particular exercise. So make that a 3. So here's my pseudo sorted array, if you will. So index 1, 2, 3, and 4. And I see that 1 is correct, 6 is correct, but these here are unsorted. So if we were to sort them, so if I put the 2 here, the 3 here, and the 5, then I would have a sorted array. Does everyone see that? So how would I go about doing this in code? So I would have what I would probably think about doing is the 2-pointer technique. And I would come through starting at index 0 and probably index 1. And as long as 1 was less than, the first one is less than the second one, 3 in this case, then I can at least say that for now 1 is true. But I'm not sure on that. So I'm going to, at the moment, I'm going to save 1 in a third pointer. And I'm going to save that because I need to compare on my next round going up. So I'm going to send him up. And I'm going to send him up to next ones. So in this case, I'm going to now compare 3 and 5. And 3 is less than 5. So I'm still good. As far as I know, after I've searched the first 3 indices, everything is in order. So I have now, I'm going to keep 1 stored because that's my first one. And I'm going to slide again. So now I'm going to go from here to here. So now I have 5 and 2, and that's not true. So 5 is greater than 2. And if I compare 1 and 2, I know that 1 is greater than 2. Or 2 is greater than 1, I mean, sorry. So now I know that I at least have an unordered piece. And it has to start at index 1 because index 0 is good. So I'm going to slide again. Slide up from here to here and here to here. So now my 2 is less than 6, and that's great. So, and then I get to my end, and this is my end. I know 6 is my end, so I can't go any further. So I know 2 then is my far side. So I know that 1 and 2, or 1 and 3 were good. So now I'm going to go and I'm going to look at the subarray. Do I need to sort? So I don't even need to sort. So all I know is that 1 is good and 6 is good. So, and that's indexes 0 and index 4. So I can say that now index 3 is my far side, and index 1 is my, so index 3 is my right side, and index 1 is my left side. So this is going to be my unsorted portion. Smiling, right? So how do I do that in code? Okay, so here's my examples. So output 5. So which ones do we need? Okay. So that's even better because now I don't even have to tell you which ones. I just have to keep a count. So what I'm going to do then is I can start a counter. So I think everyone's probably used some type of counter before in a program or an incrementer. Done this. So count plus plus. So maybe I use a counter to go through as I click through, and I find out that once I get to here, it's a little easier. When I get to 3, I am already out of order because that needs to go there. So I know that I'm going to start at this level here for my subarray, and it's going to go all the way down to here because 9 is also out of order. That has to go over here. So it'll end there. So I just have to capture the fact that I hit 1, 2, 3, 4, 5 indices and just return that number. So going back to what we did before, and we did our pointer, and we stored, so actually we probably only need 2 pointers, so that was 1, 3, 5, 2, well, 6, and now 7, because I put 1 extra 1 in there. 2, 3, 4, 5. So I would get here to this one to 3, and I'd find 2 up here. So it wasn't would be until I have to go back and place the 2 here, where I would have to count out those spaces back. So maybe we leave the first pointer here and then we increment through, or we do this. We increment through, but we're going to stop our first. So he's going to stop here. So this is our first guy coming from here. He's going to stop there. No, he's going to stop. We're going to stop him at 5. Because that's where we're naturally stopped on the increment. Go to 5. Our second pointer, follow on here. We get our first display here at 3. Index 3. He has to go back to 5. So we can swap here. And if he bounds back, maybe, to test the previous index here, we switch again. Maybe then we catch our 1 to 3 to return 3. We'll have to, let me start writing the code. All right, so this was a technical interview course, so that's why we'll see the interviewer on here quite a bit during these. So we know that we're going to be, we've talked about understanding the program. We set up one test case. Some other test cases we might want to look at is what if the array is null? There's nothing in the array at all. How do we deal with that? How do we deal with if it's already sorted? Do we return null? Do we return 0? What do we do? Or what if the entire array is unsorted? How do we return everything there? And then if everything's unsorted, how do we deal with that in code? All right, so we're matching. So I match this up with the 2-pointer piece. All right, and then using the 2 pointers to travel through and to go through our through our array to find the subarray. All right, and now we're going to do kind of a partial walkthrough of how we would solve this without code. Okay, so they want to go from the right to the left. Okay, maybe that's a good idea too. So one is, yep. Actually, I can see this actually more effective because I was trying to figure out how do we go back. So if we start each way, and then we go and we compare, that goes up. And we already know that that's wrong. So we can already stop at this point here. So our left stops at 3. And then we go from the right. Oop, going the wrong way on my mouse, sorry. So then we go to the right, and that's good. That's good. Oop. And we have this, we've come here because 0 is greater than -1. But if you look at this here, this is an edge case where if we were to just simply captured this here, we would not get the right answer, right? Because in reality, we have to add this part here. Because 1 is greater than both 0 and -1. So simply putting the -1 here, the 0 here, the 2 here, and the 3 here is not going to solve this effectively. So we have to figure out how we're going to deal with that 1. All right. So extends bigger numbers. Bam, bam. So somehow we're going to have to go back when we write the code to capture that 1 if need be. So in here, oh, we still doing this? Okay. So I'm going to open up, I have this code already done. Let me just navigate it to there. Thought I already had this one done. Squares, compare trees, bubbles, bird search, reverse words. Average sum, string. Oh, I guess I did not have this one already done. Sorry, folks. All right, Ariana, have a good night. Oh, we keep going in and out. That's right. So, all right, let me reshare here. All right, so here's an example of the code for this. Let's just extraneous. So fine. So array. We go A. Here, I'm going to go new. Go back to my slides and get that numbers. Take this one. All right, so if I run this, I'm expecting then to return my numbers of my, oops. Public int. Oh, is that because it's not static? Yeah. Oh, do I need to add the math? Int Allen length R0 for the right, going through the length, going through I plus 1, J, so left and right, and then I'm returning, oh, be here all day if I don't do the critical printing of the result, right? Everything's working, because I didn't spell it right. Five. So just as we had before in the example, so we actually compensated for the fact that we only got 4 in our first one and we got all the way back to 1. So we did that by doing 2 things. So I have two integers that or two variables that I built here. Left, which is L. Let me expand this so it's more understandable. Right. Left. That's everything in there. Oh. Left. Right. Left. So what we're doing here is this isn't the most efficient way, but it is an effective way. So we have a nested for loop. So we have two for loops. One of them's nested, I and j, and we're running through for the entire length of the array. And we're starting with the we're starting at 0 and 1. So this is the way that I went through it, and that's how I explained it. And then we're going through and we're determining which is less than. And then if it's less than, I am going to change right will equal to whatever the value is of j, and then whatever the value is of, or not, I take that back, not the value, but the indice of j, the indice of I. So, because what we want to do at the end is we want to take and do math based on the indices going from 0 to, in this case, what, 6, 7? So we are tracking our indices, not our values. And we can go from here, copy this. No, that's not it. All right, tutors, no, it is. Where's my on tutor? Okay. So Python tutor is a visualizer of our code. I'm going to click on the subgroup here of Java tutor. And eventually this will open up. Okay. So the only thing you need is to make sure your class is public, and mine was not. So I'm going to paste our code in here, and we're going to visualize the execution. All right. So we have 115 steps according to this piece. So we're going to have to do those nested for loops, which is going to take a little bit of time. But we're just going to next on through here. And we have our array. We're going to send our array into our find unsorted subarray. So it is now going to determine what left and what right is equal to. So left is equal to 7, and the right is equal to 0. And we knew right was going to equal 0 because we initialized it that way. And then I is equal to 0. I'm just going to J is 1, so they're going to start going through their cycle there. They get to the second one. We still haven't even gotten into the if statement yet. All right, now we're in the if statement. So our right, is it greater than J? It is. So now our right equals to 3. And our left, we just got there, and the lowest is 0. So we're going to keep going through. Okay, we have a new match for right. It's at 4. And we should have, in a second here, a new match for left. Maybe. Eventually, we're going to hit to index 4. Oh, that is index 4, sorry. So 4 and 0. So we've already hit all of, we've hit all of our, we hit all of our indices earlier. I don't want to go through it all. So 0 and 4, those are our correct indices. So then we're going to go through this little equation here. So our left, our right, which is 4, minus 0, so 4, and that's greater than or to 0. And then right minus left, 0 plus 1 is 5. So that's going to end up being 4 is greater than 5. So 5 is going to be our return value. I think if it's not even going to really do that math for us there. But basically, that's how we got our return value. And as you can see, I'm just going to go through here backwards. Most all of our steps are going through I. We have to go through J all those times to flip I. So this is a lot more, it's probably a lot less efficient than going from right to left. All right, and we're doing 434. Okay, let's look at one more example here. All right, so this is, we're going to do now is our sliding window. So this is where we're going to basically take our 2 pointers and move them at a set distance apart from each other and read what's inside. So in this case, our set distance is 3. So we're going to set our window for those 3. Okay. And what we're trying to find in here is the maximum value when we're adding the maximum sum of these 3 indices. So 8 for the first 3, we slide over 1, and now we're at 7. So 8 is still our max. Going to slide over another one. Now 5, 1 is now 9. So 9 is our max. And our last one is, we're going to get to 6. So 9 stays our max. So 9 is the maximum number that we can have. So basically what we're doing here is, where's my draw? I don't want it red. Okay. So we're going to start with, basically, we'll start with this one. Pointer here, and a pointer here. And we're going to be reading the values from each of these pointers and doing that addition. So what we're going to need is we'll need a set piece here, or another variable to, in this case, max sum, that we'll use to hold that value. So first one's 8, and then we'll slide over to these 3. And so now 8 is greater than 7, so max value doesn't change. And these pointers will have we'll add those up. Of course, 9 is greater than 8, so now 9 is our winner. So the maximum sum of the subarray, then also the smallest or longest subarray of finding a sum with the most distinct characters. So those are two different examples of when to use the sliding window technique. So using the two pointers approach. So we can really, you don't really need the 3 pointers. I'm just trying to depict that for you in real life, how you would do it. So I'm going to go back to my other Google. Here's my other Googles. Or the Firefox, I should say. I'm going to stop, share. I'm going to go back to Repellent. I'm going to go back to our repels and subarray maximum sum. Okay, so we have 2 parameters that we have to pass into our new method that we're going to call subsum here. We have the array, and we need the key, if you will, that k. So that's going to be the amount of indices that we're looking at to determine what our max is going to be. So what we have created down here is, let's go make this a little more interesting for 1, 3, 0, 2, 4. All right, so what we're looking to do here is we're looking to return just that sum. So we're going to do that by passing both the array and the key through. And as it comes in, we're going to first grab the length of the array, and we're going to hold on to that. And then we're going to hold on to a new variable. In this case, it's just going to be result. And then we'll grab the larger sum. And then we're going to go into our for loop. All right, so we're going to, in this case, we're going to go across with our window size based on the k. So we're going to go through and find the result for our additions going through. Then we're going to take our result, and it's going to be our largest sum. All right. Then we're going to go through the array again, but this time based on what k now equals to, which is going to be our 4. And then we're going to go through and we're going to take our largest sum and compare any other values that might be in there to make sure that it is truly our largest sum. And then we're going to take the largest sum on our second time pass and compare it to our result from our first time to determine if we truly have the largest sum. So if we look in here, we have 4. So our window is 4. So our first grouping is going to be here, and that's going to be 7, right? Our next grouping of 4 is again going to be 7. Our third grouping is going to be 8. Our fourth grouping will be 9. So our 9 should be what we have as our result when we return it. So I'm going to run this, and we get 9. And we can pull this again back over here to our PyTutor. I'm going to edit this code, paste in our new, and then see, because we avoided nesting those 2 for loops together, now we're down to 41. So we could do that. We could have done the same thing with brute force and nested those for loops. And again, we probably would have had somewhere up to like 120 operations. But here we only have 41. So we have lessened our use of the CPU to do our calculations. We only have to do 41 instead of 120 or so. All right, so we're going to step through. We get our array, we get our k, and then we send it up into our new method. So we're going to run through. We're going to get our array length, which is 7, and our result is 0. Our largest sum is 0. And now we're going to go into our first for loop. So I at 0, our result is going to be 4. Okay, and why is that result going to be 4? Because we are taking only the value of the first indice and putting it in our result. As we step through and I goes to 1, we're going to go and we're going to now take 2 and put that into our results and add it in. So it'll go to 6. We'll do that again. We'll add 7. When we get, now we have 7, and then we'll do the final one when we add 0, and 7's not going to change. All right. And now we're going to go through, and now we're at I equals 3. Okay. Now we're at 4. So because we're beyond, we only went to k, now we're going to go and we're going to get our result. So put our largest sum as our result is 7. Right, and we're going to go through, and now I starts at 4. And our largest sum went up to 8 because we now have the 4 or the 7. Let me go back. It's 1, 2, 4. So largest sum is 7, but we're going to end up changing that because when we get here to this largest sum, we're doing k or index I, which is now 4, and we're going to compare that to the I minus k, which is the 4. oop. So our largest sum at that case is now 8, and result will change to 8 as we go through. Then we're going to now compare at I is 6, so this is our 2. And we went from a result here, our largest sum. So all we're doing here is our largest sum is and minus the k value. So we're just adding up everything here together. And because we're adding up everything here together, instead of just going basically sliding and doing those 3 equations, we're able to dumb ourselves down because we're just going to add the 4 to the um, to the other groupings. So we're minus 4 out of this 4, so we go to 7. And then we minus the 3 out of the 2, we go to 8. And then now we're out here and we're minusing the 2 out of the 1, and we go to 9. Okay. So I'll kind of step through that again. I'll write it down as we go. So our first loop, we captured this, and we came up with the number 7. So our second loop starts here. And we're only looping this far. But what we're doing is we are going back and we're taking the index here and we're taking it off of here. So essentially we're just capturing this value here now. So we're going back, adding up everything but this index here. And then we'll do that again when we get to 5. So we'll go through, take 2, and this comes to 8. This, of course, was 7. And then on our third time through, coming up to here, because we're starting at we're now at 6, and we're taking 2 and subtracting this index 6 from k. So we're getting down to this one here. And now we're at 9. So instead of kind of sliding and doing each manually, we kind of fudged it a little bit and programmatically to make it more efficient, if that makes sense. So we'll go through, and we're at, again, index 6. Our greatest value is 9 because now we're only looking at these last ones because we've subtracted these all out. And that is now our key piece. Okay. So let's change this up a little bit, and we'll go we'll put 5 in lieu of the 0, and we'll change our k to 3. Now, just glancing at this, I can already tell you, right, that 5, 4, 3, so that's going to be 12. That's going to be our main point. But we just want to step through. So we have, again, 42 steps. We start off with our length of 3. Our k is 3. Our result is 0. And then we're going to go through. We're going to add up the first 4 indices, so 0 through 3. And when we get 0 through 3, we should get, or 0 through 2, sorry, because we're at case 3. So we should get 7. So, and that's what we have. We have a result. So we're going to go down, and we have now gone through. Largest sum is now going to equal to result, to 7. Now we're going to jump into the for loop, the second for loop. And because we're at 3, we're going to start at index 3. So I is 3. And what we're going to do is we're going to knock off that 5, or that 4, sorry. And so we'll end up adding up and we'll get 8. And because we're going to add up to 8, we're going to beat 7. So result will change to 7. Then we'll go up to 4. And we'll end up going 4, that's going to equal 10. So at some point, largest sum is going to go to 10. Then our result will go to 10. Then we'll go up to 5. And then that'll equal 12. So our largest sum is 12. And then go to 12. And then go to 7. We only get 9. So the result stays at 12. And we return 12. All right. So that's an example of the sliding window. And that's a more optimized version of it in programmatically to depict what we're trying to do in real life. So let's go back to the slideshow. So we have our slideshow. All right, so sliding windows. That's it. You guys have any questions on what we covered tonight? You think you could do it on your own?
Like, pardon the kids in the background, but it is a good refresher. I've done some of this before with C++, but it's been like 3 years ago. So, and seeing it in Java, I know we're going to have to do it in Java at Texas A&M. So it's good to see it all play out.
How about you, Selena? Was it good for you? Can you speak? Or do you have to type? How you doing, Ray? I know we did some of this already a couple weeks ago, so hopefully this was a good, whatever you caught was a refresher for you, Ray. Sorta, and maybe some sort of new stuff. Because you didn't remember. All right. Gotcha. All right, I'm going to stop recording here.